Hello and welcome to our mathematics lesson. Today we are making an introduction into a new topic under numbers and algebra, and the topic that we shall be covering for the next 6 or so lessons, we shall be looking at the topic indices and surds. Under these particular topics, there are a number of concepts that we are going to discuss and that we are going to learn. I'd like to welcome you so much in enjoying this series of lessons. Now, the first aspect that we are going to learn as part of our new topic is on the index notation. You will be able to appreciate in this particular case that indices is the plural form of index. If it is one, it's called index, and if there are many, we refer to them as indices. So we are going to learn how we can be able to indicate or how we can be able to note down indices if there are many, or an index if it is one. Number 2, we are going to look at the laws for the indices, and we are going to divide it into 2 sections, where in the first section we shall look at the laws that are normally put in application whenever we are dealing with multiplication and division. Then later on we shall be able to look at the laws that are normally used whenever we have a power of an index, or if that particular index is 0. So we are saying, number 2, we shall cover the index laws. And we are saying for the first case, we shall look at the index laws for multiplication and division. So whenever you have 2 indices of the same basis and you want to multiply, what is a law that you can easily be able to use whenever you are multiplying indices? And then if you are dividing, again, which rule are we going to apply? Because we understand that indices can either be divided or they can be multiplied, and sometimes it can be cumbersome if we decide to deal or to multiply through all those particular indices. So it is much easier when we develop a law that we shall use during multiplication and division. Number 3, we shall look at the 0 index and power over power. Again, here we are going to develop a law that can be used to solve a scenario where we have a 0 index and when we have a power over power. The fourth aspect which we are going to learn is index laws application, and this should be in the extended format. What if we now combine, or we have a series of multiplication, division, power over power, and sometimes a 0 index? What shall we do? Number 5, we shall cover negative indices and in this case the power of that base in this case is going to be a negative number. So when we have negative indices, what must we expect, or what is expected of us? It's also something that we shall be learning. Number 6, we shall learn something about scientific form or what we call the scientific notation. Scientists have their own way of writing numbers, and of course in relation to indices or to powers. We shall be able to look at that. Next, we shall look at scientific notation. When we are using significant figures. Whenever we shall be using the significant figures. Number 8, we shall have fractional indices. And this is the point where we shall now introduce Surds. And during the development of this extension on Surd, we shall be able to appreciate that there are some numbers which can never be written as a fraction. That is A over B, so long as B is not equal to 0. Such numbers will be referred to as irrational numbers. And whenever we get roots of such numbers which do not or which cannot be written in fraction, then we shall be talking about the surds. Then the last aspect which we shall learn in this topic is on simple operations. With surds. And whenever we talk about operations, these are addition, subtraction, multiplication, and also division. So these are the 9 topics, subtopics, which we are going to cover in this topic, indices and surds. I'd like now to move forward and make an introduction on the index notation. But first, before I may be able to proceed, I'll maybe take us back a little bit. Why is this topic on indices important? We shall be learning this topic on indices because it has a wide application, especially in the scientific arena or the scientific field. In the case we are talking about the growth or decay of certain materials, then this topic is very, very much important. For those scientists who are in the industry, and especially who are doing research on certain bacteria, they understand very well that these bacteria normally multiply or they normally divide. Like for example, there's this bacteria that causes a very dangerous disease called tuberculosis, which is called a mycobacterium. Tuberculosis. This is a very dangerous bacteria that when the scientists were doing research, they discovered that it's a serious bacteria that keeps on multiplying 2 times after a given or a fixed period of time. So whenever we want to establish the growth of such bacteria, then the topic or application, or we now apply what we have learned on indices for you to be able to know at what rate is it growing, and whenever you develop an antidote, at what rate can you be able to slow the growth of that particular bacteria. Then we have some other substances which have been known to be reducing with time. Such a process of them reducing over a period of time is the opposite of growth, and we refer to it as decay. So again, when these materials decay, that means they are reducing in terms of either size or the number. Again, the topic indices is very important when it comes to calculation of those decays. I like now to move straight to our first subtopic, which we said we are going to cover on index notation. Now, from previous experiences, we have been able to do multiplication using or going by a certain factor. Let's say we are given 5 multiplied by 5 multiplied by 5. The 5 we are talking about is a factor, and you discover that when you multiply 5 by 5 by 5, you are going to get, or this one can be written as 5 raised to a power of the number that particular factor was multiplied. In this case, we are multiplying 5 3 times, and therefore we raise this 5 to 3 times. So 5 by 5 by 5 can be written as 5 raised to 3 or raised to power 3. Again, if we had x multiplied by an x, multiplied by an x, multiplied by an x, multiplied by an x, how shall we be able to write this one? Again, you can be able to see that there is a constant factor, which is xx. And we have multiplied x how many times? 1, 2, 3, 4, 5. Therefore, you jot down that factor, x, and you raise it to the number of times that factor has been multiplied. In this case, we have multiplied x how many times? 1, 2, 3, 4, 5. Therefore, that means that we raise x to power 5. Now, these two scenarios here, 5 raised to power 3 and x raised to power 5, are what we are referring to as the index notation. And during the introduction, we said index because it is 1. But whenever we are talking about so many of them, then they become indices. Now, there's a name or special name given to the base or these particular factors, which we have been able to multiply them with respect to the numbers given, that is 3 and 5. Now, this number 5 and x, they have a special name. We normally call it a factor or the base. Then we have got the 3 and the 5, which are written on top of that particular base or on top of that particular factor. We refer to them as exponents or sometimes we refer to them as power of. So they are referred to as powers. So in this case, 5 has been raised to the power of 3. 5 is the base or the factor. 3 is the exponential or the power. In this case, x is our base or the factor, while 5 is the exponent or the power. So in a nutshell, this is how we can be able to jot down an index, or we can be able to represent an index notation. There are a few clarifications we also want to make. Number one is that indices, which is the plural of the word index can be used to represent a product of the same factor as we have been able to look at. Number 2 is about the base, and we are saying that the base is the factor in the product. We are going to look at different scenarios or different cases on how these ones are applied. Number 3 is about the exponent, which is now our index, or we use the word exponent, or we'd say it is the power. So it's the number of times a factor is repeated. And if we say that a factor is the same as the base, is repeated, then we have also something we're going to learn on prime factorization. Where we're going to appreciate that during prime factorization, or this one involves writing a number as a product of its prime factors. It should be remembered at this particular juncture that whenever we talk about prime factors, these are prime numbers, and they are numbers which usually have only 2 factors, that is 1 and themselves. If we can be able to give examples of prime factors between 0 and 10, 2 is a special prime factor, and it is the only prime factors on all the integers that is even. When we talk about 3 has got only 2 factors, that is 3 and 1 and itself, that is 3. When we talk about 5, it's also a prime number or a prime factor, because it can be divided by either 5 or 1. When you mention about 7, the same happens. 7 is a prime number since it has got only 2 factors, that is 7 and 1. Lastly, whenever we have a factor raised to the power of 1, we should be able to appreciate that whenever you raise any number to 1, it remains that same number. Then whenever you have a number, let's say 5 raised to 1, then this number is going to remain as 5. Let us try to look at how we can be able to apply these cases. Right, this is example 1. We're supposed to write each of the following. In expanded form. Number 1, we are having a raised to the power of 3. Number B, we have got x, y, the whole of this raised to the power of 4. Then number C, we have 2a cubed b squared. We are supposed to write these numbers back to their original form, or that is the expanded form. In solving these particular questions, let us begin with the first one. You have been told that we have a raised to the power of 3. A is our base or our factor, then 3 is our exponent or our power. And in this case, as the power tells you that the exponent has been multiplied or has been repeated how many times? 3 times, because of that particular power. And therefore, we are going to have a repeated 3 times multiplied by a multiplied by a. So this, whatever I have on my right side, is the expanded form of what I have on the left hand side. Part B, we are having xy, and this particular compound has been raised to the power of 4. This tells us that there is a common factor or the base, which is xy, and is being repeated to the equal number of what we have on the power. And in this case, we can be able to say that xy has been repeated how many times? 4 times. That is xy the first time, xy the second time, xy the third time, xy the fourth time. And therefore, in expanded form, this shall be xy repeated 4 times, xy repeated, xy this shall be xy multiplied by xy multiplied by xy multiplied by xy. The base has been repeated 4 times, xy, 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 xy. So the power or the exponent tells you how many times that particular factor or the base has been repeated. The last, number C, we are having 2, a raised to the power of 3, b raised to the power of 2. Now in this particular case, 2 has not been repeated, so it's independent. A has been repeated independently 3 times. B has been repeated independently 2 times. So in expanded form, we are going to have the first constant, which is 2, multiplied by A has been repeated 3 times, going by its power, and therefore this shall be A multiplied by A multiplied by A 3 times. Then the last bit, we have got B, and B has been repeated twice. Therefore, we shall have B multiplied by B. And therefore, whatever I have on the right hand side is the expanded form of the index on my left hand side. This is how we can be able to write numbers from index notation to their original expanded form. Example 2, we want to write those numbers now in expanded form and try now to evaluate. Write each of the following in expanded form. And then evaluate them. In evaluating, that means we now give the expected response or the correct answer. The first one, we have 5 raised to the power of 3. Number B, we are having -2, this one raised to the power of 5. Then part C, we have 2/5 raised to the power of 3. So we now have these three scenarios in which we now have the real integers, and we want to first write these particular numbers in expanded form before proceeding to evaluate or solve them. Now the first case, we are having the index 5 raised to 3. This means that in expanded form, the factor or the base 5 has been repeated 3 times, and therefore we are going to have 5 multiplied by 5 multiplied by 5, which in this case, when you multiply 5 by 5, you get 25. When you multiply 25 by 5, you get 125. So we have first written the number in expanded form, that is 5 3 times, or repeated 5 3 times. Then when you multiply or you evaluate, we get the answer to be 125. Part B, we have -2 raised to the power of 5. The factor in question here is -2, and we are repeating -2 5 times. So when we write this number in expanded form, we are going to have -2 multiplied by -2 multiplied by -2 multiplied by -2 multiplied by -2. That is, a number -2 has been repeated 5 times, and we are taking it to be the whole of it as -2 because the bracket is encompassing the negative and the 2. So when we multiply that, -2 multiplied by -2, this one will give us +4. -2 multiplied by -2, this one will again give us +4, because a negative multiplied by a negative number will give you a positive number. Then the result is multiplied by the last 2. So 4 by 4 will give us +16, and when you take +16, you multiply by -2, we are going to get -32. So the result, or the expected answer here, is -32. Later on, we shall be able to appreciate that whenever you raise negative numbers to odd powers, the numbers will remain to be negative. But when you now raise the same to an even number, like for example we raise this one to 4, then that means we will have not looked at the remaining -2, and therefore the answer will have been +16. The last one, which is 2/5 being raised to the power of 3. So that means that the factor, which is 2/5, has been repeated 3 times, and therefore this in expanded form shall be 2/5 multiplied by 2/5 multiplied by 2/5. That is the number written in expanded form. Then when you now go ahead and evaluate, the numerator, which will be the 2 to the power of 3, will give us 8. The denominator will give us 5 by 5 by 5, which is 125. And therefore, the expected correct response to this particular question will be 8 all over 125. Our next example. We want to see if you are given a number in the expanded form, can we be able to reduce them and obtain the index form? The question reads, write each of the following write each of the following in index form. Number 1, we have 6 multiplied by x, multiplied by x, multiplied by x, multiplied by x. Number B, we have 3/7 multiplied by 3/7 multiplied by 4/7, 4/5, sorry, multiplied by 4/5 multiplied by 4/5. Then the last one, we have 8 multiplied by a, multiplied by a, multiplied by another 8, multiplied by b, multiplied by b, multiplied by a, multiplied by b. So you discover that in extended format or in extended form, these numbers are very huge, and scientifically we like to reduce and work with as smaller numbers as much as possible. So for the first case, for us to be able to write this in index form, we need to look at the factors. In this case, we have the first factor, which is 6, and then the other factors, which are x. And as you can be able to see, 6 has been repeated only once. So we can write 6 raised to power 1. Then we have the x's, which have been repeated how many times? 1, 2, 3, 4. So the factor x has been repeated 4 times. So that means we write the base x and we raise it to the number of times it has been repeated, which is 4. So when we simplify this, 6 raised to 1 is 6, multiplied by x raised to 4. That will be our answer of this expanded form in its index form, and it can be read as 6 x raised to power 4. Now in this case, we are having 2 different factors. We have the first factor, which is 3/7, and the other factor, which is 4/5. You can be able to appreciate or see that the first factor, which is 3/7, has been repeated twice, and therefore we can write down that particular factor. It has been repeated twice, so we raise it to the power of 2. Then we have this other factor, which is 4/5. It has been repeated 3 times, so we write 4/5 raised to the power of 3. When we try to simplify this, multiplication will be eliminated, so we shall have 3/7. This one is raised to the power of 2, 4/5 raised to the power of 3. So this is the expanded or the index form of the expanded form on our left hand side. For the last case, we have got 3 different factors, and these factors are namely 8. You can be able to see 8, and 8 has been repeated twice across this form. We have 8, we have 8, so it has been repeated twice. We are having a, which has been repeated across this particular equation how many times? 1, 2, 3 times. And then we have got the last factor, which is b, and b has been repeated how many times? 1, 2, 3 times. So in index form, we can be able to say that we have got 8, we have a, and we have b. 8 has been repeated twice or 2 times. A has been repeated 3 times, so we raise it to the power of 3, and b has been repeated 3 times. So you can be able to solve the first part because you understand that when you square 8 or when you raise 8 to the power of 2, the answer is 64. So this shall be 64 a cubed b cubed. Example 4. We now want to look at the case of prime factorization or the prime factors. We are told express 48 as a product of its prime factors, but strictly in index form. During the introduction, we say that prime factorization involves writing a number as a product of its prime factors. Now here we are having 48. We are going to develop the prime factors of 48. And the least prime factor, which is a special prime number, is 2. So 48 divided by the first prime factor 2, we'll get 24. That means we can still be able to continue with that other root. Again, this is a prime factor of 2, and that 2 goes into 24 12 times. 2 still has a chance, and 2 can go into 12 6 times. Then lastly, we have 2 as a prime factor, which can be able to go into 6 3 times. So these numbers 2, 2, 2, 2, and 3 are the prime factors of 48, and they can be written as 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3. Those factors makes up 48. Our question requires us to write these particular prime factors in index form. So we need to know what or how many factors we have in this particular place, and how often or how many number of times have they been repeated. So we have got 2 factors, that is 2 and 3. And clearly you can be able to see that 2 has been repeated 1, 2, 3, 4 times, while 3 has not been repeated, or we only have 1 3. So this shall be 2 raised to the number which is 4, and this one is raised to the number in which it has been repeated, which is 1. So simplified, this shall be 2 raised to 4 multiplied by 3. And now this is in the index form. When you finally decide to multiply this, you will end up back with the answer, because 2 raised to the power of 4 is 16. When you multiply 16 by 3, you end up with 48. So this is the correct response. So now I want to consider a number of examples that touches on the several aspects we have learned. that is writing numbers in expanded form, expressing an index in its expanded form and evaluating, and also writing the index form of a number, and also prime factorization, which involves factorizing a number using its prime factors. Evaluate each of the following. We have A, 5 which has been raised to 2. Number B, 2 raised to the power of 3. Number C, 3 raised to the power of 3. And number D, negative 4 raised to the power of 2. So we want to evaluate. That means you obtain the correct answer for these particular questions. And the first step is always to write the number in expanded form. So for the first case, we are having 5, which is a factor repeated 2 times, going by the power which is there, which is 2. So this shall be 5 multiplied by 5. And 5 multiplied by 5, we understand, is 25. So that is the answer to the first question. Here, a factor 2 has been repeated 3 times. So that means we have 2 multiplied by 2 multiplied by 2. Now 2 by 2 will give us 4. 4 by 2 will give us 8. So that tells you that whenever you raise 2 to the power of 3, the answer or the response will be 8. 3 raised to the power of 3, that means we have 3 repeated 3 times. That means that we shall have 3 multiplied by 3, which is 9. 9 multiplied by 3, which shall give us 27. And then lastly, we have negative 4, which has been repeated twice. So that means we have negative 4 multiplied by another negative 4. We understand that whenever you multiply negative integers, the result will be positive. So negative 4 multiplied by negative 4, we shall have positive 16. So this is the required response for this particular question. Number 6, write the number that is the index of the following expressions. Number 1, we have 4 cubed. Number B, 6 raised to the power of 4. Number C, negative 3 raised to the power of 7. And then D, x raised to the power of 11. The question requires us to write a number whose index or indices appears here. The other name for what the question is requiring us to find is to write these particular numbers in their expanded form. So like in this case, we need to first write these numbers in the expanded form and then move on and solve them for us to be able to get the number whose indices are written down below. So for the first one, we have 4 repeated 3 times. So that means this shall be 4 by 4 by 4. And 4 repeated thrice will give us 16 by 4, which is going to be 64. So that means whenever we raise 4 3 times, the result is going to be 64. We have 6 which has been repeated 4 times. So that means we have 6 by 6 by 6 by 6. Whenever we multiply 6 times, this 6 by 6 will give us 36. 36 by 6 will give us 216, and then finally multiplied by 6 will give us 1296. Second last, we have negative 3 repeated 7 times. So that means we're going to have negative 3 multiplied by negative 3 7 times, negative 3, negative 3 multiplied by negative 3, 1, 2, 3, 4, 5, multiplied by negative 3, multiplied by negative 3, 1, 2, 3, 4, 5, 6, 7 times. So when you take negative 3 by negative 3, we are going to get positive 9. When you take 3 by 3, it again gives you positive 9. 3 by 3 will give us positive 9. Then lastly, by negative 3. So when you take 9 by 9, it will give you 81. 81 multiplied by 9, it shall give us 729. Then multiplied by this negative 3, which shall give us a negative number, which is 2187. And again, this tries to explain what we had initially said, that whenever you raise a negative base or a negative factor to an odd power, then the result is going to be negative. Then here we are having x, which has been repeated 11 times. So that means we have x times 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 x. This is those are x repeated 11 times, and this will of course give you a number which is still the same as x raised to the power of 11. Example 7 on the prime factors. We can have a question that states that you write down the prime factors of the following numbers. Number 1, we have 6. Number 2, we have 15. We have 30. We have 77. So the first, of course, prime factor here shall be 2. 2 we require to multiply it with 3 for us to end up with 6. So this means we have 2 by 3, and these are the prime factors for that. The smallest prime factor on 15 is 3. And that means for us to go back and get 15, we need to multiply 3 by 5. Therefore, the two prime numbers for 15 is 3 and 5. For 30, we're going to begin with 2, which is the smallest prime number. So that will be 2. We multiply by 3. 2 by 3 will give us 6. That means we require to multiply 6 by 5 for us to end up with that 30. And they should be able to write these prime numbers in the increasing order. Then lastly, 77. This means that the smallest or the first prime number shall be 7, and you'll be multiplying 7 11 times for you to end up with 77. So those are those particular numbers written in their prime numbers. We'd like to consider a final example. on this particular question, where we are told a fat cat that was initially kilogram reduces its weight by 10% each month. This is a question now on decay. How long does it take for the cat to be at least half its original weight lighter than its original weight? And we should be able to write our answer correct to the nearest month. So we have a problem which is a decay problem, or the weight of this cat is supposed to be reducing by a given fraction for a given number of months for us to end up with either at least 6 kg. That means it should have lost more than half of its original weight. And each month we are told that this cat is losing 10% of its mass. So initially the cat was 12 kg initially. So after the first month, it's going to shed weight up to by 10%. That means the remaining mass will be 90% at the end of the first month. That shall be 90 all over 100. Now, given that this weight is supposed to be decreasing for a given number of months, we shall raise what we have here to that, let's say up to X months, for this cat to weigh at least less than 6 kg. Let's say 6 kg, which is now the least mass. 90 divided by 100 is 0.9. So this shall be 12 into 0.9 raised to the power of x is equals to 6. Now for us to be able to solve this, we are going to take this 12 to the other side. That means we are going to divide through by 6. And this will leave us with 0.9 raised to x to be equal to 6 divided by 12. This shall give us 0.9 raised to the power of x is equals to 0.5. Now for us to be able to get the value of x, we need to introduce logarithms. And in this case, we introduce logs on both sides. So this shall be log of 0.9 raised to x is equals to the log of 0.5 on the right hand side. So whatever you do on the left hand side, you must also do it on the right hand side. The laws of logarithms can allow us to rewrite this equation. This one comes before into log of 0.9 to be equal to log of 0.5. And then finally, for you to be able to get the value of x, you need to divide through by log of 0.9. So you shall have log 0.5 all over the log of 0.9. This will give us the value of x to be log of 0.5 divided by log of 0.9 will give us 6.5. And because we have said that we at least round it off to the nearest month, then for this cat to have lost more than 6 kg, then it will take it, this one rounded off shall be 7. So it will take the cat 7 months to shed its weight to a tune of less than a half what it was originally weighing. I'd like to give an assignment which you can try later on. We are told that a shareholder says that he can triple your investment or money every year. So you decide to invest $1,000 with him. The question is, 1, how much should your investment be worth in 5 years? Part B of the question, how many years should you invest? How many years should you invest if you are hoping for a total of at least $100,000. So try working out this particular question. Now this brings us to the end of our discussion, where we have been able to look at how we can be able to write numbers in their index form. That was the main aim. We have also been able to look how those numbers appears in the expanded form, and at the same time how we can be able to do the prime factorization. Next time we meet, we shall be looking at the index laws for both multiplication and division. Thank you.